Okay, so we can see from the picture of a tree diagram that this is going to be about probability. We've got lots of information here. So she has 10 CDs in a holder. She's got a favourite group. She has 6 ZX in the CD holder, so she must have 4 of the other CDs that are not ZX. She takes one at random, she writes down whether or not it's ZX, and she puts it back. So we're not doing without replacement. So the first choice, the event is that she's choosing a CD. So there was 6 out of 10 which were EDX, so that's why we've got 0.6 here, 6 out of 10, 0.6. So must be 4 out of 10, because there was only 4 of the other type, which is 0.4. Notice, as usual, that these two numbers, because they're coming from a single event, add up to the total probabilities of 1. The second choice, well, because she's put the CD back, then when she chooses the next one, there's still going to be 6 out of 10 chance that she chooses ZX. So that again is going to be 0.6, and because the probability has got to add up to 1, that'll be 0.4. The fact that she chose not an EDX the previous time, because they're independent, it doesn't affect what goes on here. We've got 6 out of 10 happening that she could have chosen the EDX, and the 0.4 there. It says then calculate the probability that Amy does not choose any out of her 2 choices. So we've got to follow the tree diagram. So she's not going to choose any EDX. So that means she's gone down here and down there. Now, because we want not EDX and not EDX, we want those 2 things to happen. They're independent. You know, whatever happened here is not going to affect these ones. So independent probabilities, we times the answers to get the final result. So it's going to be 0.4 times 0.4, which is going to give us, well, 4 4s are 16. We've got 2 digits after the decimal point in our sum, so we must have 2 digits after the decimal point in our answer. 40% of 0.4, 0.16. So the answer here, 0.16. Again, just be careful that you consider all the possibilities. In this case, there was only one possibility to meet what we wanted. If they'd have asked what was the probability of one of the CDs being not an EDX, then we'd have had to have considered that would have given us one not EDX set, and then this and this would give us one. So we'd have had to work it twice and then add the answers up together. Okay, so that's tree diagrams and independent probability.